Okay, so our project is about the cost of living in different cities around the world. This is our website. So first we have our data, our um our graphs and plots that we made. So I made the first two. This one is about the correlation between cost of living plus rent index and the local purchasing power index. So as you can see, as like the cost of living plus rent index gets higher, so does the local purchasing power index, and that's what the trend line shows as well. And the colors are all the different cities in this scatter plot. And this is a histogram, and it's basically just about the cities, basically how much cost of living plus rent is in different cities. So as you can see, like somewhere like Zurich, Switzerland is much more expensive than like Mysore, India. And I'll pass it on to Amir for these next two plots.
So we have a correlation heat map, and as you can see, it's generally light. And we had to clear a lot of the values because they were kind of useless and cluttered up the heat map. So we had to remove those and made it look more visually pleasing, appealing. So as you can see, there's there's a few purple spots, but it's not that bad. But it just makes it look presentable and not that, but you can visualize how different things can correlate with each other and how well they actually correlate. And next we have the scatter matrix. So what this is essentially it's like a correlation heat map, but it's been scattered. So there's a diagonal line towards like the middle, and that's just different values correlating with themselves. But as you can see in the top right corner, um, the data is a little bit more spread out, and that means that these two values don't really correlate as well as others. So as you can see with the cost of living index and restaurant price index, it correlates pretty good because it's closer to a straight line than the other one is. And I'll pass it on to David from machine learning models.
Yes, machine learning models. Hello. Okay, so this is gonna be our machine learning models. We did five models, and we're gonna just go over them all really quickly, and then show you which one that works the best for us. So the first one that I did, decision tree, made in 1963 at in the University of Washington, doing a project. Basically, how it works is it's a supervised machine learning model that takes they like predicts off of a previous set of questions that were answered. So you can see it's like a tree. If you see the graph, you can see a decision from one thing turns it into two other outcomes. Some pros and cons. One pro is that it's really easy to explain. As you see now, it's like pretty easy. One con is that it can take a really long time to calculate, and it can also, and often does, especially for us, can overfit. Our outcome for the train value was 1. Our test value was 0.98, and but our mean square error was 4.7, which was not the best. So we had to pick something else. And I'll pass it on to Katherine for her support vector regression.
Yeah. So the model I worked on was support vector regression, or SVR for short. It was invented in 1963, and SVR is a supervised machine learning algorithm, and it uses the same basic idea as SVM, a classification algorithm, but it applies it to predict real values rather than a class. And some pros are it thrives in high dimension, and it's pretty fast at predicting. And some cons is it's not good for big or messy data sets. And in the orange, you can see that this is our best hyperparameters we found for SVR. And the outcome, the train score was 99% accurate. The test score was 92% accurate. However, the mean squared error was really high. It was over 100, so we're not moving forward with SVR. Now passing it on to Sophia.
So I did the random forest machine learning model. It was made by Tin Cam Ho in 1995. And basically it takes a bunch of decision trees for like the input, and then the output is based on the prediction of all of those all of those decision trees. And basically, some pros and cons is that it can be used for classification and regression. It works well with nonlinear data and large data sets, and it has many parameters. Some cons are that it doesn't work well with linear data. It's known to overfit, which is bad because it's not going to be very accurate in predictions, and it's a bit slow to train. These are some hyperparameters that you can use for a random forest. I used a number of estimators and random state, and our outcome was the trained data was 98, the test data was 97. We ended up not using this model because other models were more accurate. Passing it on to Amir for Lasso Regression.
So lasso regression, lasso means least absolute shrinkage selection operator. It was invented in 1986, only to be popularized in 1996. So what lasso regression does is it's a variant of linear regression and uses shrinkage, and shrinkage helps make data more accurate. So pros and cons with this is it avoids overfitting and it's fast when fitting data. But one bad thing is certain models might make it unstable. So for hyperparameters, we found that line in orange was the best. And you can change a few things, but if you keep it like this, it'll give you the best accuracy. So for our accuracy in trained data, it was 99, and test was also 99. And our MSE was pretty low, which makes it our second to best model. But I'll pass it on to Nne Ezi for linear regression.
Linear regression was earliest seen in 1805. The success of linear regression depends on the variables being, the outcome and input variables being having a linear relationship, and it also doesn't consider outliers. Some pros is that it performs well in data that's linear, that's separated, like that has a linear relationship, and it's easy to implement and efficient to train. While testing out the parameters of linear regression, no matter the parameters I change, like no matter what I changed or tampered with, the accuracy levels came out the same. Our outcomes was the train accuracy was 1.0, test accuracy was 0.99, and mean score error 0.0007. So it was our best.
And down below, we created a comparison table to easily see all the models, their accuracy scores, and mean squared error, so we can decide which model to use.
So we created a graphic representation of the outcomes of each of our models. And this graph here is the mean score error of each model. And we can see that linear regression is the lowest. And below it is the accuracy score for the test accuracy scores for every model. And linear regression and Lasso both have 1, but since linear has a lower mean score error, we concluded it's our best model.
Okay, on to the about section and kind of like our story when we do it. So first and foremost, what is cost of living? Now, cost of living is pretty self-explanatory. It's how much it costs to live, but it's not actually just referring to your house or your apartment. It's referring to everything. It refers to the money you have to spend on from gas to groceries and all that stuff. Why do we do it? Well, I mean, it's pretty obvious why we did it. Everyone needs somewhere to live. And being able to just search something up and find out exactly how much it costs to live in that certain area would be extremely useful for anyone trying to move somewhere new or just trying to get out of where they are. How do we do it? Well, the website's pretty easy to follow. You just need access to internet and then kind of like the website. All you have to do is put in the name of the city that you want to search up, and it will pop up your cost of living, and all the other indexes that we've added to the chart, and which you will see later in a sec. Future stuff we want to add on top of our main thing, it would be great if we could have like a budget system like House Hunters, where you can put in how much money you would be willing to spend, and we'll give you like a range of cities that you could live in. And we'd also like to have a picture next to it so you can see what city you're actually like going to if you don't know the city. And we'd also be providing a interactive map showing you the surrounding areas in case you're worried about that. And again, we are the Green Titans, and this is our cool, very cool team. And I'm lastly going to pass it on to Katherine to show everyone what our prediction model was.
Yeah, so we're going to import Pickle and store a linear regression model in a Pickle file. And a Pickle can store a file that allows us a faster execution in predicting values, so we don't have to manually go through the training testing in our models. And we created two graphs using linear regression, the predicted values and the actual values. And from this, you can easily see that linear regression is very accurate in predicting. So this was our best model. And down below, this would be like a basic overview of how the prediction would work. So you would enter in the city name, and it would give you the cost of living index below. So for like Almaty, Kazakhstan, it would be 38.68. And then Bangalore, India. So I'm just going to give some examples of cities. And from these three, you can see that London would be the most expensive because the cost of living index is 66.5, while somewhere like Almaty, Kazakhstan is only 38.68. And yeah, that's it for our presentation. Thank you.